Welcome to the new topic of Elementary Statistics, Chapter 4, Discrete Probability Distribution. This topic is composed of three sections. Section 4.1, Probability Distribution, Section 4.2, Binomial Distribution, and Section 4.3, More Probability Distribution. Let's begin first discussing Section 4.1, Probability Distribution. By the way, what is probability distribution? Probability distribution is a statistical function that describes all the possible values and likelihood that a random variable can take place within a given range. Section 4.1 Objectives. First, how to distinguish between discrete random variables and continuous random variable. Second, how to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution. Third, how to find the mean, variance, and standard deviation of a discrete probability distribution. And fourth, how to find the expected value of a discrete random variable. Random variable. Random variable represents a numerical value associated with each outcome of probability distribution. It is used to quantify outcomes of random occurrence. It is required to be measurable and typically real numbers. And it is denoted by X. Example, X is the number of sales calls a salesperson makes in one day. X is the hours spent on sales calls in one day. There are two types of random variable. The first one is discrete random variable. Discrete random variable has a finite or countable number of possible outcomes that can be listed. The value of this is obtained by counting. Example, X is equal to the number of sales calls a salesperson makes in one day. It is an example of discrete random variable because the number of sales calls in one day can be counted and can be listed. Another example of discrete random variable is the number of students in a class, because the number of students in a class can be counted. Another type of random variables is continuous random variable. Continuous random variable has an uncountable number of possible outcomes represented by an interval on the number line. Example, X is equal to the hours spent on sales calls in one day. It is an example of continuous random variable because the value is obtained by measuring. Example, discrete and continuous variable. Determine whether each random variable X is discrete or continuous. Explain your reasoning. Let X represent the number of Fortune 500 companies that lost money in the previous year. Remember that discrete is countable and continuous variable is uncountable. So this situation is an example of discrete random variable because the number of companies that lost money in the previous year can be counted, and it is 500. Second, let X represent the volume of gasoline in a 21-gallon tank. Remember that discrete random variable is obtained by counting, and continuous random variable is obtained by measuring. And this situation is an example of continuous random variable because the amount of gasoline in the tank can be the volume between 0 gallons and 21 gallons. Discrete probability distributions. In finding the discrete probability distribution, first, we must list each possible value the random variable can assume, together with its possibility, and it must satisfy with the following conditions. First, the probability of each value of a discrete random variable is between 0 and 1 inclusive. Less than 0 and greater than 1 is not part of a discrete random variable. 2. The sum of all the possibilities is 1. In the future, if you find that the sum of all the probabilities is 1, but the value of each discrete random variable is not between 0 and 1, still it is not a discrete probability distribution because discrete probability distribution must satisfy with these two conditions. Let's proceed. Constructing a discrete probability distribution. Let x be a discrete random variable with possible outcomes x sub 1, x sub 2, through x sub n. 1. Make a frequency distribution for the possible outcomes. 2. Find the sum of the frequencies. 3. Find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. 4. Check that each probability is between 0 and 1 inclusive, and that sum of the probabilities is 1. Example: constructing and graphing discrete probability distribution. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. By the way, histogram is a graphical display of data using bar of heights. The taller the bar graphs, the higher the data. So let's see in that table in the right side, score x and frequency f. In score 1, there is a frequency of 24, in 2, 33, in 3, 42, 4, 30, and 5, 21. So in constructing a probability distribution, we should find first the total frequency. So the total frequency is 150. So divide the frequency of each score by the total number of individuals in the study to find the probability for each value of a random variable. So we have now the total frequency of 150. So we should divide each frequency by 150. So probability of 1 is equal to 24 over 150 because 24 is the total number of frequency of 1 is equal to 0.16. Same thing as probability of 2 is equal to 33 over 150 equals 0.22. Probability of 3 is equal to 42 over 150 equals 0.28. Probability of 4 is equal to 30 over 150 is equal to 0.20. Probability of 5 is equal to 21 over 150 is equal to 0.15. So the discrete probability distribution now, so we have now the table labeled as x and p of x. And x, so we have the frequency 1, 2, 3, 4, 5. Then each probability of discrete random variable. For 1, we have 0.16. In 2, we have 0.22. In 3, we have 0.28. In 4, we have 0.20. And 5, 0.14. Then, we should look if this is a discrete probability distribution. Remember that discrete probability distribution, that the sum of all the probabilities is 1, and the number of each discrete probability distribution must be between 0 and 1 inclusive. Let's find out. So this is a discrete probability distribution because each probability is between 0 and 1. 0.16 between 0 and 1, 0.22, 0.28, 0.20, and 0.14 is between 0.1, and it lies in the inclusivity of the discrete probability distribution. And if we will find the sum of all the probabilities, 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14 is equal to 1. Thus, the situation is a discrete probability distribution. So we should graph now using histogram using the following data. Because the width of each bar is 1, the area of each bar is equal to the probability of the particle outcome. Also, the probability of the event corresponds to the sum of the areas of the outcomes included in the event. So we should graph now using histogram. So we should put our score, which is the x, and the probability will be the y values because the probability or the y values depends on the score. So as you have shown, so we have 1, score 1 is 0.16, 2 is 0.22, score 3 0.28, score 4 0.20, and 5 0.14. So we have now the histogram. Remember that the taller the bar graphs, the higher the data. As I said earlier, that if a distribution is a probability distribution, then it must satisfy with the following conditions. First, each probability must be between 0 and 1 inclusive. Second, the sum of all the probabilities equals 1. Let's see if it satisfies the first condition. 0.216, 0.32, 0.288, and 0.064 is between 0 and 1. And let's find out if it is satisfy the second condition, which says that all the probabilities equals 1. Yeah, all the probability is equal to 1 because the summation of probability of x is equal to 0.216 plus 0.432 plus 0.288 plus 0.064 is equal to 1. Thus, the distribution is a probability distribution. Example, identifying probability distributions. Determine whether each distribution is a probability distribution. Explain your reasoning. Rx is 5, 6, 7, and 8. Probability of 5 is 0.28. Probability of 6 is 0.21. Probability of 7 is 0.43. Probability of 8 is 0.15. Let's find out if satisfied with the first condition that all the probability must lie between 0 and 1 inclusive. Each probability lies between 0 and 1. 0.28, 0.21, 0.43, and 0.15 is between 0 and 1. But it does not satisfy with the second condition that the sum of all the probabilities is equal to 1 because the sum of this probability is 1.07, which is greater than 1. The sum of all the probabilities in the distribution must be always equals to 1. So this distribution is not a probability distribution because it must satisfy with the two conditions. Example 2. Rx is 1, 2, 3, 4. Probability of 1 is 1/2. Probability of 2 is 1/4. Probability of 3 is 5/4. And probability of 4 is -1. Let's find out if it satisfies with the first condition that all the probability must lie between 0 and 1. 1/2 lies between 0 and 1 because 1/2 is equal to 0.5. 1/4 lies between 0 and 1, which is 0.25. 5/4 is not part of the inclusivity because 5/4 is equal to 1.25. And -1, so -1 is not part of the inclusivity. Thus, it does not satisfy with the first condition, hence it is not a probability distribution. Though the sum is equal to 1, but it does not satisfy with the first condition. Probabilities can never be negative or greater than 1. So this distribution is not an example of probability distribution. Let's proceed. We are now in finding the mean of the discrete probability distribution. The mean of the discrete probability distribution is represented by the 12th lowercase letter of the Greek alphabet, the mu. Mu is equal to the summation of the x times the probability of x. Each value of x is multiplied by its corresponding probability and the products are added.